all the products as a function of time, which is given by rate is equal to change in concentration over the change in time. Now, the reaction rates specifically tells us how much of a reactant or is consumed or a product is formed at a given specific time. We'll use one example, let's say in the Haber process, the formation of ammonia. So let's say the formation of ammonia in the Haber process. So ammonia is formed from nitrogen gas and hydrogen gas, which give us ammonia gas. Now, from these two, you first balance the equation. Place a 2 here and a 3 here. Now, if you want to get the rate of, let's say, ammonia over NH3, or let's say nitrogen, rate of consumption of nitrogen gas, we can say that its rate will be given by the change in concentration of nitrogen gas divided by the change in time. Now, this is normally given by the initial or the final concentration of N2 minus the change or the initial concentration of N2 gas. Here it's N2 final minus N2 initial. Now this is the concentration, that is concentration divided by the change, or let's say the time, the final minus the time, which is the initial time. You use for hydrogen, and also the same use for ammonia. But as you will observe, the rate of consumption is normally negative, because at the beginning the reactants are at a higher number compared to the products, because the reactants are consumed while the products are being formed. Therefore, there will be more products at the end of the reaction, while at the beginning of the reaction the reactants will be at a higher concentration. So let us do one example over here, practical one. Formation. So you are given that the rate of formation of NO in a reaction is given by 2 NO Br, which is a gas, minus the reaction is 2 NO gas, then plus bromine gas. Now is reported to be, now do that the rate for this reaction, its rate is 1.6 times 10 raised to the power negative 4 moles per liter per second. Per liter per second. Now you are asked, what will be the rate of consumption of NOBR? So the question is the rate of consumption of NOBR in the reaction. So we said that the rate for this chemical reaction will be given by N, or rather 1/2, which is this NOBR, d over dt, which will be equal to, now since this is the rate of consumption, it will be decreasing, so therefore it will be a negative. So the rate of formation of this, it will be a positive, so it will be a half. Now the concentration of NO gas, we change in time, then which is also equal to the rate of formation of bromine gas. The rate of formation of bromine gas, because the coefficient here is 1, so we don't have to indicate it. So BR delta T. Now what we do know is that the question is asking the rate of consumption of NOBR, which is this. So the rate of consumption of hydrogen bromide, hydrogen oxide bromide is given by, is equal to, now the rate of formation of this gas, and this will be given that the rate of formation of NO2 gas is this. So we substitute this into this equation, therefore we say that this is equal to 1.6 times 10 to power negative 4 moles per liter per second. Therefore, if you want to get the rate of formation of this, we simply cross multiply with the reciprocal of this on both sides, such that multiply by -2 by -2, multiply both sides by the inverse of this, or the reciprocal of this. When you multiply both sides by the reciprocal of -1/2, which is -2, this side you remain with D, which is the rate of formation of nitrogen oxide bromide. It will be equal to, now, -2, which is -1/2, times 1.6 times 10 raised to power -4 mole per liter per second. Now if you work this out, what you'll get is 2 times 1.6, 2, it will be 3.2. Times 10 raised to power -4 moles per liter per second. So you ignore the negative sign since it is the rate. In the rate, as I said in the beginning, it will be reducing for the reactants, but for the products it will be increasing. But since it is a rate, we don't consider the negative. Or rate of consumption of this is equal to 3.2 times 10 raised to power negative 4 moles per liter per second. And that is how you solve that question.